ನೀವು ಇನ್ನೊಂದು ಕಡೆ ಲಾಗ್ ಆಗಿ ಇದರ ನಿಮ್ಮ ಮೊಬೈಲ್ ಅಲ್ಲಿ ಆದ್ರೆ you also see if it is working or not. In case an stream error is there or ಒಂದೊಂದ್ಸಲ streaks ಬರುತ್ತೆ. ಇಲ್ಲ ಈಗ ವರ್ಕ್ ಆಗ್ತಾ ಇದೆಯಲ್ಲ. So you're able to see both of us. Right? Okay. Can audio. Yeah. You can start. ಯಾರು ಬೇರೆ ಈ ಕಡೆ ಬನ್ನಿ. ಯಾರು ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಬಂದಿಲ್ವಲ್ಲ? ಇಲ್ಲ ಸರ್. ಮತ್ತೆ ನಿಮ್ಮ ಹೆಸರು ಎಲ್ಲಿದೆ ಇಲ್ಲಿ? ನಾನು ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀನಿ. ನಿಮ್ದು ಮಾನಿಟರಿಂಗ್ ಟೈಪ್. He is not a participant here. You are a monitoring. ಸರಿ ಹೋಗಿ ಹಂಗಾದ್ರೆ ನಿಮ್ ಬೇರೆ ತುಂಬಾ ಕೆಲಸ ಇರುತ್ತೆ. ಇದು ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಏನಾದ್ರು ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ಚಾಟ್ಸ್ ಅಲ್ಲಿ ಹಾಕಿ. ಮ್ಯೂಟ್ ಅನ್ಮ್ಯೂಟ್. ಓಕೆ. Should we wait until somebody comes? Okay, we'll start it. We'll start and do a small introduction. Hello, good morning. Good morning. I am so this course is about physical modeling of prototypes. Normally, whenever somebody talks about modeling these days, it means CAD models. Physical model is actually, when you take some what do you call, use cardboard or use anything and make a model out of it, which is a little similar to oldest Meccano, if you remember. Then after Meccano came some constructors. After that, this what do you call, Legos things came. Then highest is probably Mindstorms next, where full computerized robots, everything we can make. That is one type. But what we wanted to explain is saying, using whatever you have within your computer, within your competence, you can also make excellent physical models. And these days, 2 other facilities are available. If you can make a good 3D computerized CAD model, the CAD model, many of the 3D packages, there are several of them, but everybody knows the, what do you call, Siemens, this thing and the other French thing, which can make models which are surfaces and also which are solids. The advantage of making this solid and surface models are, I will just show you. It's a big cap. So, if you take a device like this, what you are able to see are the surfaces. Okay. And we do not know what is inside that or anything. So such things, are very, very convenient and easy to make. Either you take some, let's say, plastic or something and remove the material by subtractive process. This is how machining is done with various materials in that. Traditionally, in mechanical engineering, there was a job called machinist, meaning he operates machining and he can do turning, he can do milling, he can do various other things. And other trades were there like welding and joining and all that. So that was basically a subtractive process. So you have a solid, you remove the various materials. And most mechanical engineering drawings, so-called 3-view drawings. 3-view drawings will have something from the front. Usually this is shown as a plan view. Something from one side, which is called a side view 1, another is side view. Sometimes, depending on the details, sometimes there will be a rear side view. From these views, the machinist was able to reimagine and make the part by capping it, by clamping it in a vise and using various machining operations. Now for us, luckily, for about, I think 30 or 40 years back, what is called additive process has come. Additive process, especially using filament thing, something, one filament will come out. That is how the whole 3D printing has come. Why it is called printing is the way that the device which drops that thing, it moves left and right, up and down. There is no Y as yet, except movement of the Y. It can go up or wherever it is there. That is how the word 3D printing has come. Now you see that, let us say you want to print this. I show you here, there is a back cap. That's in that. If I remove the back cap, here there is a gap. Now I really don't know what is inside this. The advantage of 3D printing is that if I make a surface model and work on the surface model by removing various materials and all, no, I can make a shell. So if you want the whole thing to be occupied, that is what typically what you get as downloadable files. You get the downloadable files on the internet. Generally inside, no, depending on your requirement, there may or may not be filled. If you want it to be filled and full, a matrix structure is made, something, no? You can see small things going up and down like that, no? That is the one that holds it together. So at least even today, the complicated machines have a support material which will hold the materials, and then after that, no final build material. And if you want even transparent, and if you want even colored, even this, and if you want even movable, and if you want slightly different consistencies, all of them can be 3D printed. And to enable 3D printing, first thing is you need to learn how to make very simple 3D models. Okay. So you must have heard about what is that thing made by Siemens? I do use my live for making the, I forgot the name. Just now I got it. And even things like sheet metal, basically sheet metal is flat. You understand? No? That is why it's called sheet metal. Sheet metal, what they do is it will be in a flat condition. After you form a blank, then you try to bend it in all the directions. So all these operations also, no, that is, if you make a sheet metal, and I got that name, it is called SolidWorks. Okay, the word solid, no? Okay, the two versions, Solid Edge and SolidWorks. SolidWorks is probably more, useful for 3D machining. SolidWorks is for all the sheet metal work and all that. But all of them basically have the same thing, saying you should understand how the original 3D material was made. Understand? No, so if it is sheet metal, you need to take a flat sheet. I will scrap and put it. Give it. Say, if it is sheet metal, it will be flat like this. Now, if you want to make a box, we all know about it. No? We can make it into 4 types. In the extreme types, we must have seen a cake box. I'm sure these days everybody eats pizza and cake. Even though you don't like it, no, you can see the other fellow eat it. If you see the whole thing is made on a flat sheet, various things are there. If you do like that, now nicely you assemble. It is hollow, it is strong enough, everything is there. However, you see in Solid Edge and SolidWorks, now you need not do that circus at all. You just need to create a solid, and there are things like shell command. If you make a flat piece, make a shell command, it will become something. If you make a box-like thing, there are some automatic, what do you call, programs, which will even make it flat and recreate it like this. At that level, it's a little complicated, and somebody has to go to the parent company, first on you must have all heard of AutoCAD. It's all made by Autodesk. So Autodesk has many of these products. Similarly, Siemens has. Similarly, that French thing, Solid, we are not able to get it. No, they also have all these models like that. This, we have made it because our students used to do it. And one more, I do not know, caution thing is, I am a member of Indian Institute of Science, and many companies, give us free packages for us to use. Because if let us say he's my student, I teach him how to use what they call Autodesk Inventor. The moment he takes a company, he knows that and he will recommend it to their people. So I get it free and he get it as a student, and everything is numbered and all that. They can go and use it like that. Like that, we have received more than a dozen packages free of cost. If you're a student, if you write to them, usually they'll give you a free license. And if you're part of a college, through your college, you can get your license, you can practice these things. So we were hoping, that many of you people, even if you don't belong to a college, if you are a what you call individual inventor, if you write to them, they will help you. They'll give you
trial. They give.
Pardon?
30 days trial.
Not just 30 days trial, limited node thing. You understand, no? You cannot make a complicated thing. You can make a simple thing, and it says usually it is time limited. Easiest time limit is 30 days. And to prevent people from, what you call, using devious methods, that is how the 30 days came. Otherwise, it will be generally saying 100 saves, 100 times you can save the file. After that, you can't do anything. So it's very good for learning. And afterwards, if you have learned from them, or if you have gone through any other coaching center, there's something called CEADD center, and several of them are there now. Through them, you can get a license. If you cannot get a license, you can go on the premises and work. All major cities and many so-called tier 2 towns have this facility. You understand? No, if you somehow learn how to make it, and then you can go there. So even this is a relatively very simple thing to make. Absolutely simple thing to make. You understand? No, because there are two parts. And here earlier, no, if you see, there's a small slope here. Can you see? Earlier, if you want to release it at a mold, you have to give what is called a mold draft. Unless you give the draft, the part can be pulled out of the mold. That is where 3D printing has made a difference. You don't need any draft for any of the objects. In fact, if you don't have a draft, it will build very well. Vertical walls can be easily built. Horizontal with supports, it can easily build. So this thing was conceived maybe around 30 years back. When I'm also a faculty in what they call Center for Product Design, now called Department of Design. So earliest, all the students, typically people who are registered for MDes, and then all the people in MTech, and then many PhD students, all of the people used to volunteer and come here. So we thought, after with our experience, and we tried to make things very, very simple. So one of the students asked, sir, you are having a PCB, that PCB is having some components, then you have shown a mold. Is it not going to interfere here? There's some circle here, there's a thing here. It's true. That is very, very valid. That is why we try to make these things. The particular answer for that was that PCB, when we made, we have used the maximum dimensions which they have mentioned in the catalog. You understand, If the capacitor is there with a given capacity, they'll give 8 plus or minus 0.5 mm. So you cannot use 8, you have to use 8.5 mm cylinder. Similarly, that whatever boss and all we have just now used, there is very much possible there is some interferences there. Advantage of this 3D printing is you don't lose much. All you have to do is run one thing like that. Stop it, see if it is matching or not. If it's not matching, you should not act like Cinderella sister saying, I will cut my leg, or no, I will cut my toe so that it will go into the glass slipper. You don't need to push it like that. Now you have to see your thing part is correct. You have to check first of all with their drawing. Have they substituted one thing? That particular case, most likely, they have substituted with a capacitor, which is a slightly bigger one. It is 0.5 mm more, but that is enough for it to interfere. Next, when you order, you have to make sure that all the components are as per that is called an outline. Outline is correct. Then you make your thing, and wherever it's interfering, you can remove a little material. That one, if you want to hide a screw, and they make what is called a counter bore. That is, the head is there, slightly small depression of the head will be there. And the one at the bottom is called a boss. So you can make certain adjustments. If it is a circular boss, removing a small portion will not matter. These things, if you play, finally, when this job is sent for production, it will fit 100%. If any mistake is there, that is probably an extraneous thing. That is where the 3D printing helps us. Don't get distracted saying some IIT has printed a whole house, somebody is printing an aeroplane and all that. They are good as news items. The reality is there is no printed house anywhere. It's only made for the demonstration. If you go inside, it rains, if the roof dissolves, don't feel worried about it. Somebody is working on it and they know how to make the best possible house like that. But for present conditions, if you know a little bit of this 3D printing, it's very, very useful in the house. Absolutely, very, very, very. I mean, you cannot imagine the amount of thing. At home, what I did is, you say, I have a mobile here. This particular mobile has already the circuitry for charging. So I need a charger. So I have purchased one, wireless charger, stripped it, removed all the parts and all, found out what is useful, and then made a box, which is also, it holds it, and then we can do it. Often people ask the question, no, hey, it is available in the shop now. Why are you making it? I am not interested in buying something. You understand? No, I have a big kitchen with everything inside. I can't go into a hotel and eat. I can extend to the family also. Family is family. Self-cooking is self-cooking. So is these things. When we make these things, very useful, it will be extremely useful. So I have made something which will be surprised, which has this, and other side, no, it has a cup warmer, so that when I'm having a cup of coffee, I mean tea generally, no, you can keep it in that without interfering. The cup warmer keeps my cup hot, and then this thing, no, keeps charging. And I mean, one of my students, no, also has these ear things, no, that also he keeps there. He'll never remove this, because for him, no, this is the lifeline and blood for everything. So all these things, you know, small things about the house, you can make it. Now we come to the important question. First question I've told you is, there are very many tutorials all over the place now on how to start with either solid edge or SolidWorks things or any other 3D modeler. First thing, that is about how to create that. Then other part of it is saying how to, various things, you know, that is also available. In between, to make this 3D printing work, there is something called stereolithography files called STL. Stereolithography means layers of layers, no? How to build, you have to make the file. So between your 3D model, and generally all 3D models, no, follow the old AutoCAD DWG standard. DWG has flat, plus it has 3D also. Later on, they went to IGS, initial graphic exchange system format. Then DXF came, drawing interchange format. These basic formats, no, DXF, IGES, and DWG are still valid and accepted by many of the things. In between, you have a patch program. And that patch program is very specific to the printer that you use. You understand, no? If you have one particular printer, you have to use that. What is the printer? We have two of them. We had Blueprint. One more Blueprint is one.
That is this one. Matchboard.
Yeah. So
Matchboard.
there is a little problem. Blueprint came to India. There is a little thing saying it is made by a Israeli company. You need not worry who made it. The political thing is not your interested. But the first thing, no, earlier they made a very, very, very stable machine, except that it's a monster. You understand? No, it looks like, I do not know, a deep freeze thing. It is so high and so big and so deep, and it will make 200 mm by 200 mm small parts. Right now, they have made them so simple now. There's one 3D printer at home. The printer looks like, I do not know, just like a normal printer.
Desktop.
Desktop, that's all. And we that will go and print beautiful things, and then we're able to get it. It doesn't cost too much. For I think around 30,000, no, you can buy it. And that has multicolor spools, everything is open, and only thing is it's not a production thing. And only one person can use. You understand, no? Not, others cannot use. So if there's one bunch of students are there, no, easily they can use full thing, no, including change of things and various things. All of them 3D print is available. For that, an STL file generator patch program is there. So if you give your thing, it will generate its own. If you give an STL file also, no, it will run the file and show you how the thing is there. So generally, no, all of them have a flat table like this, and you have that nozzle which is moving and printing. So some of them usually, sometimes the nozzle moves, sometimes this goes up and down. After starting this, on screen, it will show you how your parts are being placed. You understand? No, it's pointless to keep on building huge thing and doing it. So if you can split it, in this case, for example, logically, it can be split into two halves, left and right. And you can build this like this, or you can build this like this. If you build this like this, it will build automatically. If you build this like this, while it looks good, it needs a lot of support material. These things, without actually carrying out the print, you can observe in their patch program. So there are many visualization things, just like you have a 3D visualizer inside your CAD package, no? There's a visualizer for the parts also. Then related to that is, it will show you how much time it requires to build that model. And complicated models takes many hours to build, but yours I expect, no, maybe around half an hour and all. And related to that is so many other things it will tell you. So you got that point, no? So we have three things. First of all, how to make a 3D solid model. Then secondly, how to convert it into STL file. Next, how to do the carry on the printing. And now why we call this physical modeling is often when you make some object like this, we can easily make the object, there's no problem, because it is made from what are called geometric primitives. Finally, after everything else is done, no, there's a cylinder, then there's a cuboid, and related to these two is a cone. These are all the only thing. And a cylinder where X, Y, Z are all the same radius will become a sphere. And it X and Y and Z is different, no? Either you can have a oblong spheroid or another spheroid. One is like a disc. You understand? No, it looks like your another one. I think it's called an oblate spheroid. Another is like a football, American football, longish like that. No, all these are basically geometric primitives based on the basic original sphere. And if one of the things is infinite, it will become a cylinder. If something else is there, it will become a cone. Something related to this is the cube also. If all X, Y, Z is same, it will become a cube. If they're different, no, you get prisms and you can get various things. No, these basic geometric primitives are all usually from the drop-down menu. From the top, it is drop-down. Earlier, some used to be a pop-up menu also. Now, right now, no, even dropped up pop-up is not there. Everything is clearly visible here. It says geometric primitives. What you can do with it, you can skew them, you can do anything. And related to these geometric primitives, we also have the so-called Boolean arithmetic, Boolean algebra. Suppose you want to make a ball. You make one ball, make another ball, and put it inside and remove the material. Now comes the thing. Because of the way these CAD programs have been made, sometimes, no, they behave very unpredictably. You understand? No, so one needs to, actually, I learned it from my colleague, Mr. Singh, saying, sir, you should not do like that. The outer ball, you cut it and make it into two hemispheres. Inside ball can be same. You can remove this material. So when we have one half, same ball, now you remove it from here, you can have. Now these two, no, you can keep together. Either you can print like this or you can print like this. These things, no, there is no option other than you are trying to practice it and make it yourself. I hope you got my point, no? All of these, this so-called Boolean operation, two of them coming together, no, it's called the union. Okay. And supposing two of them, one is coming, you want the in-between portion, no, that is called the interference pattern. Then you got Boolean difference. And these things, no, you need not specially learn or anything. You can, what do you call, so many, I feel, no,
a lot of practices.
Yeah, a lot of programs and exercises are available. And you should do that because it was part of a course, I had to learn the hard way. And he had to learn even harder because he had to learn three things. First of all, no, whether that object can be, I mean, can it be made at all? First of all, does it make any sense? Then second thing is how to create the 3D model. Then after that, how to convert it into the, what they call STL file, which can be printed. The second part, no, I'm completely unaware because he's there, no, I'll dump it on him, he'll manage it himself. Luckily, these days, no, there are some people who will give the service to you. Followed, no, somebody who wants to give a service to you. And then the ones we know are all simple ABS material, which is typically, maybe 60, 70 degrees. Beyond that, no, or PVA, no, that element is called PVA. PVA is also about 70, 80 degrees. No?
Maximum 70, sir.
But their melting and forming point will be 100.
They will be melting at 100.
But so, these materials, no, what we know is only meant for the shape, not for the function. But we have full-fledged metallic 3D printing machines elsewhere in that. We have a huge center for additive metal 3D printing. There it does it slightly separate. In one of my lectures, no, it shows it uses a sintering method. Inside, you have that sintered powder. The laser goes and melts everything which we want remaining. No, it's shaken off. and inside I have a beautiful pot. So these machines are there, but sadly, not sadly, no, but it's impractical. I'll be confusing you if I keep on, what do you call, unnecessarily showing those things. What you can manage is how conceive a product saying what we want, and simplest since this is related to electronic products, no? Things like printed circuit boards and all that. Here, several times he has cautioned me, well, all this looks good. Unless you have it in your mind, you cannot get it. So he showed me what he has learned from the Swiss experts. They were trained by Swiss experts here. You need to take a graph sheet. Since we work in millimeters, we can take a millimeter graph sheet. And what all you want now, you lay out those things on other, cardboards and all, adjust your thing wherever it is. And part of it is where the inlet and outlet connections are coming. On one side, no, you have power supply, and all these occupy space. They're not just two dots. PCB may have two dots, but the actual box, no, the enclosure needs to have connectors, connector here, connector there. Similarly, lot of displays. So how the displays sit inside, no? So he had given an old thing which we were using, I think in 80.
90s.
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 Okay. So you take the cardboard, and because it's for a class, no, various things, including transformer, including all these connectors, and now already the boxes are made and kept there. So he will demonstrate on a OHP like this. This is how you do everything. And then after that, now in front of them, crumple it and destroy it so that they can't say, give it to me. No, give it to me. No, they will take their own project and all that. So that is how now these beautiful things have come. I'm sure many of you have these. What is this? AC remote. If you say AC remote, now say there's a beautiful display here. Then there is something here so that you can hold it. And this is where no, the business of aesthetics comes into picture. You've seen that, no? There are some keys here. Can you see? Then there's a display here. There is something here. You see how these things are arranged. This is best arranged. You see here, there's a display. And you see here, this line, everything, all of them follows a certain aesthetic element. These aesthetic elements make sure that the project is presentable. And this is where it makes all the more sense. When you make a 3D model, second part of the 3D model is you can do all these things, all the chamfering and the rounding off in the corners and everything. And magic is most packages can convert this solid with a surface texture and with the reflection, with the color, with the thing and all that. A fully absolutely black colored box, you cannot see it all absolutely. Edges usually carry a highlight. That edges carry the highlights. So when you see the edges carrying the highlights, then only our objects are visible fully. These things are all built into it, and people are working on the development of the packages. They know all about lighting. Then they know about anything. So there is something called Renderman and Penguin things are there. Renderman is a standard which makes things visible and standard, rendering and all that. Right now, they're very much specialist things. If you now see, for example, the moment you see a newspaper, first thing, if you remove all the what you call political and there's one new apartment block is there. Only half price, sir. One in Bangalore, half price is 2.5 crores. Full price is 5 crores. And the way they make that, the bottom it says artistic conception only, like there's nothing there. If you go there, it'll be a big ditch with some, I do not know what it is like that. And if you see that whole thing, there are rendering packages which have made things like that. So if you go there and stand there, you'll be surprised actually saying it is exactly looking like what they have put in the picture like that, which is, I do not know how they're able to make it. Okay. So the magic is, now there are 4 of these things. First of all, how to make a simple 3D model using Boolean. Boolean logic is very good. But before that, you have to make a plan view, show how much spaces are there and all that. And part of it is all the component drawing should be available for you. It's very convenient if you have it. And if you go to the supplier, usually the documents are all available online with them. Followed, no? Then after making this layout and you making a 3D thing, now you can very easily, orient it in different directions and see how it looks. And if you go through that rendering packages, you can make them see. Also next is where the 3D printing part comes. There, you have to be familiar with at least one of the batch programs, which will convert either your STL file or your DXF file into something which is presentable there, and you carry on with your printing. Online, these things are available now. There's no problem. You just need to try it. If you try it, I'm confident it will work here because our students are able to do it. We have nearly, I think, 800 students. They're able to make them very easily. Okay. So thank you. I've spoken what all I wanted to speak. And kindly ask questions. Any of the questions, you can type also.
I see that nobody, somebody was joining.
Oh, Suranjit Costa.
Yeah.
Why is it come so late?
It's okay.
Okay.
Yeah, you have any questions?
Oh, he's Suranjit.
You can introduce yourself.
Hello, very good afternoon, sir.
Yeah.
I am Suranjit Costa from Indore, Sage University. So it was a session regarding that prototyping fast, right?
Yes.
So actually, I was going through all the classes that is being shared, and it was quite interesting. There are so many new things that I came across and understood the concept. Earlier, it was so vague. We were not actually lined up that how a prototype is actually developed. So this course is literally open up a quite broad view that how we should go about from idea to designing the enclosures and what are the things are required in that. So it's like I required more insight, right? How fast we can do this? What are other things that to be taken care?
So already we have explained.
Just now you missed it. First half an hour explain. One more time I will tell you. He's the person who has asked about the adhesive interference. No. The thing is, whenever you want to make a product,
Yes, sir.
there are three stages. First is somehow in your mind, you have to conceive this product. And to conceive
Yes.
this product, you can see existing products. That is called present practice or state of the art, present art. So many of them say all mobiles look one way. If I take this touch cell, touch cell looks like this. All touch cells look like either round, occasionally
Right.
square, occasionally you have what you call button cells, you have coin cells, and you have standard these cells. Dimensions
Right.
are. So you need to have all the component information, then you need to have some idea how these things look. And using various 3D modeling packages, for example, most commonly used is SolidWorks and SolidEdge.
Yes.
And you should create the solid model. After you create the solid model, you have to check for various interferences. 1 minute. Various interferences and various things. So I have two cells here. How these cells go inside. So you have here, I have a back cover.
Yes,
How
sir.
the cells go inside. Now I need to keep the cells. I have to go here. All this can easily be checked on the 3D model.
Okay.
Very
Okay.
easily you can check them on the 3D model. And the advantage of 3D models is, let us say, suddenly AAA cells is not sufficient. You require AA cells. It's very easy
Yes.
for us to play around and increase dimensions.
Scale it.
Okay.
Scale it easily. The 3D
Yes.
scaling and all related to scaling is about this cavity here. Right
Mhm.
now, they're independent things, but in the
Yes.
other things, we have what you call bidirectional associativity assembly issues. In the bidirectional associativity assembly, this is typically, generally all our AI cells, are 2 inches long and half inch wide. That is 13 mm diameter and 50.4. These things are slightly smaller.
Okay.
And
Yes.
45
Yes.
and the diameter is 8 mm. So if you type that now, if you type these things, this also will automatically go up like that. But not
Okay.
all programs. You need to have the assembly bidirectional package. Normally these things don't have. For you, it's easier to get these things, make this. Once your solid model is ready, next
Okay.
you need to make something such that it can be printed in a 3D printer.
Yes. Okay.
That particular thing, file which is used is called an STL file. You can
Yes. Yes.
see anything,
Yes.
stereo lithography file. To
Generally,
create it,
generally while doing it, you save it as STL.
Okay. Okay. Sir.
all the basic programs, will have STL things. Sometimes
Yes.
STL will be automatically accepted because it will show how one object can be created. Now, in the 3D machine itself, now you see, you'll have a base material.
Yes, sir.
It will start printing like this. Now,
Yes, yes. Upward direction.
the orientation of the part is very important. So this is made in two parts. So it can
Mm.
print like this,
Yes, 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 yes.
can
Right,
print
sir.
like this. If you print like this, there's a big nuisance because the hollow will get filled. So
Printed.
usually there is a rendering software, no, which will show you how many you can print. If you have this, no, one piece you can
Yes.
print here, or you can put
Yes.
all the top pieces in one file and all the bottom pieces in another file, and one next
Another.
to the other as a set. This particular thing, no, it's again a rendering software, usually which comes with the printer. And the
Okay.
3D printer itself, has various other things, just like your G codes, for CNC machines. G
Yes.
code will give you what is the tool to be used, what is the tool path, and what is the optimizing, and then we have a turret, no, which tool it will select from the turret and all. Equivalent of that, the 3D printers will have. Simple thing is, at what temperature does the filament melt, and what is the
Yes.
material of the filament, and which filament we have to use. Most 3D printers will have a minimum two. One
Mm.
for the support material, one for the actual build material. Support
Mhm.
material, why separately, means that is made such that you can put it in a
Dissolves.
dissolving solution. Sometimes that is the simplest alcohol. Sometimes it is some other small thing with a little soap-like thing, there, and that it is heated and it is agitated. And with that,
Yes.
the all gets melted. The main build material now will be separate like that. So these are the two minimum. But very primitive things what we have now, that itself is complicated, often comes with only one material. So that one material thing now, wherever support has to be done, wherever small support has to be done, no, it will make a small thing. It's only a small
Okay.
thing here like that. After you remove
Okay.
it, and with the knife you can remove it, and it'll be good enough.
Okay.
And you can take a file and file it off and make up.
Okay.
And the
Right.
magic is now they've become so sophisticated that thousands of pieces can be built. If you have the file from,
Yes.
you as designer have made it solid, and then the
Mm-hmm.
printing thing is available. You just have to give it to the printer and they'll do it. Hopefully,
Yes.
now you will all be ready for the future. That is how the course was started. Now
Yes.
you ask Mr. Singh, he will be able to tell because he has done a few hundred.
Yes. No, actually, I am from AIDS, uh, artificial intelligence and branch, and we are developing a startup. Actually, we are having a patent, and we are trying to develop. So I was no idea how to go about it. So the most challenging part is how to create that 3D model. The software we are not aware because it is like SolidWorks. We are not that comfortable in those. So I was like, I should have a preliminary idea of what are the elements that goes inside before designing a 3D model or concepts. So regarding that, I joined this particular course. So that's what I was looking into, how this product need to be developed, how I should convey my messages to my peers that what need to be developed.
Correct, correct.
Correct.
That was the challenges that we are facing right now.
Good. Actually, you need not buy a software. You get trial versions. Just try with those things, and then after that, you can convince your peers and then get that thing.
So, which software will be at this stage we should be go for and try in
Oh,
a,
so
is
many
there?
are come.
No, no,
Actually,
we have.
Okay.
The thing is,
Yes, actually, sir, I have gone through. There are so many
yes,
available in the market,
exactly.
yes,
See,
and it's so confusing deciding which should.
correct.
I'm sitting in the what do you call government lab where all the software companies are free to give any software we want at any number of seats like this because once let us say you as a student work here, once you go back, let us say you worked with Solid Edge, which is extremely good. You will not pick SolidWorks because SolidWorks you are familiar. The moment you get the license, you'll start doing like this and maximum within 24 hours, you can make your product. So they're very sure you students will get it. And after you leave the job and go there, they will continue to support you for about 1 month. Later on, no, that thing will pop up, the pop-up saying, kindly you buy this package. And the second part, no, we are not familiar with what is the package that is required for you. Military people have their own thing because they
Yes,
have
yes, sir.
metallic things and high temperature things and all that. And
Mm.
people who are in the display business, no, they make yearly models and gifts and all that. No, they
Yes.
also have their own thing. They use acrylic, and
Okay.
they have software which which will cut the acrylic, which will also bend it like that. Is how you get all
Yes.
the beautiful acrylic things with the bend and all that. Basically a sheet only, but it's bent like this.
Twisted.
Yes, 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 sir. Right.
Yeah. And secondly, if you let us say you want to make one what do you call prize for your college, where
Yes.
somebody is holding a billiards ball, then
Mm.
you can have a thing like this. You can have all the dents and all that. No, the whole thing can be printed as one solid in the 3D, and
Okay.
we can give various things. We can give a gold color, and the
Yes.
ball itself now can be made into a separate thing. And in fact, there's something which you can do like that. You can make it rotate. All these things, no, there are
Okay.
packages and your skill and how to do it. What
Yes,
to
yes,
use
sir.
and what you need, we have no clue. And
Yes, 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 right.
that is the
Definitely,
problem.
definitely. Right, right. Okay.
Since you have asked, no, I suggest three important things are there. One is that Siemens SolidWorks, another is the what they call SolidEdge, and also Autodesk has many inventor and many of these things. You go right to those
Yes.
people, tell them your requirement, saying we
Okay,
are
sir.
a startup, we are thinking like this. You suggest all of them will come and they will show you. And every town, everywhere, no, the display people are there, they will show you. It will not be very costly. After you
Okay.
are convinced it is useful, no, you can get a trial version. It is fully
Okay.
usable, but trial meant for 30 days or some,
Okay.
it will have 300 saves
Sales or
are
something.
limited to 10,000 nodes like that. No, you can get all those things.
Okay,
If
sir.
you want further up now, for example, if you want it to be analyzed using triangles, that
Okay.
is very, very expensive. If you want
Okay.
stress analysis or if you want light
Yes.
reflection and all that, no, those are very, very, what do you call, expensive. But these
Yes,
days,
sir.
no,
Yes, sir.
everything is made by this 3D solid packages only. And
Okay.
it's automatic rendering only. Is it not?
Yes, yes.
Yes, yes.
Yeah.
Got it, sir. Got it. Thank you, sir. Thank you very much.
No, I'm very
Good, good,
happy
good.
that there's one active person no, who wants to try these things.
Yeah, actually, I tried a few of the recently, but they were online. They're not that good. I was unable to get good hands-on. So it was like on a desktop only, some like you suggested, Autodesk and SolidWorks. So that I will definitely get it and download and will work around it. And if I get any issue, I will definitely get in touch with you, sir.
Okay.
Say, for example, the car people, no, they
Yes.
use CATIA. That is why if you see the electric cars,
Yes, sir.
no,
CATIA, yes, that is for
every
car.
vehicle, every
Yes.
6 months or so, no, very
Mm.
complicated shape and even that glass inside, no, headlights, LED, everything.
Yes, sir.
But how are they able to? Earlier they used to make 10 years. Now they're able to make a model in 10 months.
Yes, yes, yeah,
And
right,
every
sir.
year
Yes,
they used to make 10 prototypes. Now no prototype. One final model will come. That's all. I still
yes, sir.
don't know how they're able to make so many things.
Changes. Right. Okay.
Right, sir. No, I can only say best of luck. You try
Thank,
and I can
sure,
only say you will succeed.
sure, sure. Thank you. Need your blessings. Definitely
Will
will.
succeed, no problem at
Okay.
all.
Thank you. Thank you very much.
No, again, related to your enterprise, no,
Yes,
people
sir.
often ask the question when Nano launched and when they
Yes,
said 1 lakh, no, they said, a stupid fellow, who will pay 1 lakh and 2 lakhs? It was a disaster because it was cheap. But
yeah.
now that new, what do you call, Morris Garage has come, no, that thing costs
Yes,
8
sir.
lakhs. People are running around the queue for 6 months to get the 8 lakh car.
Yes, 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 sir. I saw that. I saw that.
Magic is actually if you sit in it and drive it, no, you will never want to sit in any other car.
Okay.
Magic.
Yes.
The thing is, all
Yes.
the things what you're telling, no, how the handle works,
Yes, yes.
glass moves, everything is automatic.
Yes. Okay, sir.
All the cars will have one slope like this, no? So left and
Yes.
right. So the glass is
Yes.
not straight, and
Yes.
glass can't move. The glass also will move like this inside. It is a guided, what you call, arc like this.
Yes.
And the glass software is there. And to move the glass up and down, there is some scissor mechanism like that. That will move the
Mm.
thing in the dark and then take you up like this. And
Mm.
there's a wheel well. Near the wheel well, there's a cut. So the glass, won't go down below the wheel well. So these are
Okay.
the software specifically designed by the companies, by the people like you, and they're able to do it.
Yeah, okay, right, sir.
So thank you. I can only say best of
Thank-
success, and you can write to the companies. They will advise you, and they will give you
Yes,
a good package also.
sure, definitely,
Understand?
sir.
And full package will cost you a crore, but they will give it to you over maybe 20 lakhs or 25 lakhs. You take
Okay,
it and start practicing.
sure, definitely, sir.
People itself supply
Yeah.
softwares.
Yeah, exactly. First
Sure.
and secondly, if you can get some engineers, you can conceive in their mind and make sketches and primitive thing, you can
Yes,
send
sir.
it to them. There are many professional services who will make these things. I was just
Okay,
now making an example saying, you see the new flats and big buildings being constructed.
yes,
All that thing is done automatically by software.
Something.
Automatically, the rendering you can see, and then inside now structural integrity is there. Whatever
Hmm.
is there, and structural integrity anybody can do, but all the services, right
Yes,
now
sir.
natural gas is there, then the electrical thing is there, then there is water is there, then there's sewerage is there. All of them into some, the 13 floors now, one button and everything is ready. Because it will take 3 months to understand
Yes,
everything.
yes, sir.
Everything is done like that.
Yes, sir. Everything has got so automated. If someone is good enough, they can be done in a day or a week.
No,
As
the
of
only thing is you should not feel threatened about it. I learned with that T square and
yes,
slide rule in
yes,
1966, 67.
yes, sir.
You wouldn't have been born
Yes, sir.
25 years old. I doubt whether you're half my age.
Yes, sir. Right.
And my classmates who are working in ISRO, they have put
Yes,
all the satellites in orbit using a what do you call slide rule.
yes, sir.
After the slide rule calculations are done, they'll bring all the packages to ISC. We had an IBM 360 and other versions. They will run it here, and sometimes that packages will give an error. So this fellow will go back and check the whole night, and then next they will put it in orbit.
Yes, sir.
You
Right.
heard of Aryabhatta first satellite?
Pardon, sir?
Aryabhatta satellite, which was
Yes, Aryabhatta.
the whole thing was done in a shed in what they call Pina, industrial
Yeah.
shed.
Okay.
And that orbital mechanics is 100% correct. Something else not related to our ISRO work, it has a short life. Then I asked him, he said, no, it was made exactly for that life. It should not work forever. It should work
Yes,
for 2.5
yes.
months. It has worked for 2.5 months. And all of
Okay.
it is done by hand.
Yes, sir. Time has changed completely.
Yes.
Yes. Okay.
So
Thank you.
thank you for listening to me.
No, it was great to through all the courses that I am going through, learning so many new things. It might be in future they will become a part of my understanding to develop more other projects and products that we are working on.
Good,
It
Basta.
was it was actually, sir, it is my opinion. It was one of the course that many of the us like we have an idea, but actually we don't know how to move around it. That is the biggest problem the startups, the ideas are facing right now. The model we are not able to create, the enclosing we don't know how to do, what are the implications that goes inside it. We are absolutely unaware. Maybe I am from AI branch, there are people from electronics, agriculture, they have idea, but they have no idea how to go around it. But this course has literally helped me out to think in that direction, that we should go about a product like this.
Okay.
Thank you, sir, for that course. Thank you.
Thank you.
Okay.
Thank you.
I see no other questions, no other people. You can stop it.
A slide. Yes.
Yeah,
So,
yeah. You can stop it.
So thank you, participants. Even if you have some questions, please go through all the videos and then carefully understand the questions and answer them. And that in the forum, if you ask a specific question, sir, how did you achieve this? We'll be able to answer that. And the thing is, you need not wait for my answer. There are other people, in the forum who will understand. Even in your, I'm sure, 10th class also, I don't think you will learn too much from the teacher. A lot of it is from your neighbor only. You'll be thinking that fellow is saying something, what is it? And he will do like this. He said, just wait. After that, after you discuss with your friend, you suddenly know that everything is perfect. A simple thing like triangle. If you join the half the sides, it's parallel to the thing. No, I never understood when the teacher told. Then my friend was there next year. No, he said, "Hey, see, if you see this, you see how it is like that." No, then suddenly it fell into my head. That is how it works like that. So the other people, that is how the forum was created. It's not a question answer for us. Among your thing, no, other people can answer in the forum. It's a very, very nice positive thing meant for students. Instead of sitting in one class in a local place, no, anywhere in the world, all over the world, we have total, I think this time now 1,500 students. All of them from all over the place are logging in and they're seeing and specific their things. Okay, so thank you.
Yeah.
Okay, I think we should take leave of you, sir, because the next session is slotted to somebody else. Okay, so thank you.
Thank you.
Thank you. Well, pass my